Welcome everyone. We are now in the next video lecture. This from here onwards, we are taking the pillars of object-oriented programming, that is abstraction, encapsulation, inheritance, and polymorphism. Okay, so first of all, we'll be taking encapsulation and then we'll be going ahead. Okay, the encapsulation basically is one of the four pillars, definitely, and you can say it is the bundling of data and methods we have already seen into a single unit that is called a class. Okay, and this helps to protect the data from unauthorized access and modification. It is like you protect your data so that nobody can access it and manipulate it. Okay, so the main idea behind encapsulation is to hide the internal details of an object and provide a controlled interface to interact with it. Okay, so you need a controlled interface to interact. So encapsulation helps you in protecting your data. Okay, so it ensures, that is, encapsulation ensures that both the code and data are kept safe from outside interference and misuse so that nobody else can access it, even the class. Okay, even the class members. When you are doing big projects, then things are shared, but you don't want someone to change the values you have given or a method you have given. You don't want that, so you can encapsulate it. Okay, so commonly we can say that encapsulation is to think of it as a protective wrapper. Okay, you have the wrapper, you have the wrapper around the sweets. So similarly, you have a wrapper here that prevents arbitrary access to the code and data by other code defined outside the wrapper. So whatever is defined outside the wrapper cannot access it. Okay, so when we can encapsulate the code and data within a defined boundary, obviously we have to define a boundary. Encapsulation promotes data integrity. What happens? What is the benefit of having encapsulation? It helps in data integrity, modularity, and code maintainability. Okay, and also it allows for controlled access to encapsulated elements through well-defined interfaces, ensuring that they are used in a consistent and secured manner. Okay, so you have to protect few things, and you're protecting using encapsulation. We'll be seeing that through examples, very simple examples. We'll be talking about the examples soon, and you will be able to understand what encapsulation is all about. So it is, in a summary, you can say that encapsulation is the process of bundling data and methods together into a single unit called a class. And it hides the internal details of an object and provides a well-defined interface for interacting with the object. This is just to summarize. Encapsulation protects the data and prevents direct access from the outside the class, which ensures that integrity and maintainability of the code. Right? So, encapsulation is important for data protection, data maintainability. Okay, and the code maintainability also. So we have few things which you can keep in mind: integrity, modularity, and maintainability. Three things which are ensured using encapsulation. Now let us look at some real life examples. My favorite, actually, one of those is umbrella. Two of my favorite examples. Now umbrella we use for protecting ourselves from rain. We can have a raincoat also, but let's talk about umbrella because this is more close to encapsulation. Now consider a person caught in rain. Just you're moving around, you're caught in a rain. So to protect yourself from getting wet, what you do? You take out an umbrella. If you have one, definitely. And the umbrella actually encapsulates the specific area under it, right? That is, it creates a wrapper around you and provides a shield from the raindrops while leaving the rest of the body exposed to the rain. So most of the time it is the upper body which is protected. So in this scenario, umbrella acts as a class encapsulating the functionality of protecting the person from rain in a specific area. Okay. And the area under umbrella is private data member that is being protected, hidden from direct exposure to the rain. We'll be seeing few things using the example also. But in real life, if you relate something with real life, it is easier to understand. Okay. So the umbrella's canopy provides a controlled interface that interacts with the protected area to shield it from the rain. So just like the this example, the umbrella efficiently provides targeted protection to the specific area under it. That is usually the head and the upper body. And it doesn't cover the entire body, but rather focuses on the part that requires protection from the rain. By encapsulating the protection mechanism in the form of umbrella, the person can easily carry and use it when it starts raining. They don't need to carry a large protective cover for the entire body. And the umbrella efficiently fulfills the purpose with minimal effort. So if you look at it from software point of view, in software development, encapsulation allows us to protect specific data or functionality within a class, providing a controlled and focused interface to interact with that data. The encapsulated data and methods are shielded from external access, ensuring that they can only be modified or accessed through the defined public method. So you can see that umbrella can be related easily with encapsulation. I'm encapsulating umbrella also. Anyway, so umbrella example is a beautiful showcase of core concept of encapsulation. Similarly, we have another example that is of a hat. A person wears a hat to protect the head from sun rays or maybe from rain also, if it is a rainproof cap. Okay, so if you imagine yourself under scorching sun, to protect yourself from sun rays, you would be looking for something like a hat, and that will protect you from the scorching sun. So in this scenario, if you look at it, hat acts as a class encapsulating the functionality of protecting the head from the sun rays. Now the head is private data member that is being protected, hidden from direct exposure to the sun. And the hat provides a controlled interface that interacts with the head to shield it from the sun. Right? So the key point you can see here is that person doesn't need to cover the entire body with a large piece of cloth. Instead, the person can carry a small hat which fits the head and protect itself from the sun rays. So by encapsulating the protection mechanism in form of hat, the person can easily put it on or take it off when needed. So when you require it, you put it. When you don't require it, you can remove it. So this is a very simple real life example to demonstrate the core concept of encapsulation. And these two, I think, should be enough examples to make you understand the basic concept behind encapsulation. So umbrella and hat, they protect the required areas only, not the entire body. So if you are not protecting the entire class, you're just protecting particular variables, data members or something like that, you are using encapsulation. Okay, so in encapsulation, the internal data, that is attributes or variables of a class, is declared as private. So use private, and we have seen the private, public, and all. So make it which makes it inaccessible from outside the class. So you cannot access it directly, and we'll see it through an example. Only the methods, which are also known as the member functions, defined within the class can access and modify these private data members. Within the class, whatever is there, you can access it. Otherwise, be outside the class, if it is a private data member, you cannot access it. This ensures that the data is not directly accessible and can be manipulated only through the defined methods, providing a level of data security and control. So you're just protecting using a private access modifier. Let us look at an example. You have, let's say, balance, and you have a name. Now, balance here is private. Okay, it is declared as private. Now we have a method set balance, which actually I'll be passing on balance and name. So it is just storing it in balance and name, which are the data members here of the class. And then we have a method which returns the balance, that is display balance. Now let us look at the next one. Okay, so this is the main class, and in this main class I'll be running this code also. We are encapsulating, we are creating an object, and with that object we are calling set balance. We are passing on 10,000 in Java. You can put anything. I'll be using some other values in the example, and we are printing display and name. Okay, see what you have here. Display, you're calling display. Here you're calling this method, and set balance method, you're calling object.display obj.name, and in this display you have the return balance, which is updated here. Okay, so you're putting the values and just printing it. Okay, remember balance is private. You cannot call it in this class by using the object. Okay, we'll see that. We will be running it in VS Code, and we'll see how it works. Okay, so give me a second. Let me go to the code, and yeah, so here we are in the code. So we have private integer balance and name, which is not private, and then we have the code. We run this code now, you can see, and I'll be making few changes to make it easier for you to understand. You can see that we have passed 10,000 now, and the value is displayed. Now let's see if I try to access here balance, right? Obj dot balance. I try to do this, and you can see that even your VS Code is showing that this is an error. Balance, int balance. See, it is private. Now what it is showing here, that this field encapsulation balance is not visible. It is not visible to this class my encap, so it cannot be accessed. You can see that VS Code has given you the error directly. Even you don't have to run it, right? You don't have to run it. You can see that there is an error already, right? So you cannot access it. All here, you can access it using a method called display, which returns the balance, and we are just displaying it here. Okay, so let me do it like this. All right, this is what we had. ob.name, I can display the name. I can use display balance method to display the balance which is there, that is 10,000 in our case, but we cannot access it directly. So this is encapsulated. Okay, very simple example. And I have one more example and I would like to show you that also. Now let's say we have a bank account class which has 4 private members, that is account number, balance, account holder name and password. Obviously they have to be protected because you don't want anyone else or any other class to access it directly. Okay, so when you're actually doing big projects and you see that a lot of people are sharing your resources, so you don't want that to be shared, so you can put it as private, encapsulate it. Now we have a constructor here, public bank account, where we are passing the values. This the dot account number. I have told you already that if you are having the variables with the same name, so if you want to store the values to the current class variables, you need this in that case. If the name of the variables are same, which we are passing through the parameter and which are in the class. Okay, now so method, we have a method to deposit money balance. You can increase and you can have the balance displayed. Withdrawal, you can withdraw and you can subtract also. You can do any transaction here. It is possible even if it is a private member. The variables here are private, but they are not private to the class. Okay, you can use it easily within the class. So we have the password and we are printing that password changed successfully. If you are changing it, now what I'm doing is bank account, creating an object where I deposit, I withdraw, I print and change password. If I want to put a new password, I can do that. Okay, you can see that password, right? But if I want to access any data member like account number directly, it will throw in error. What I'm doing right now is actually using a constructor and calling the methods there, right? Like get account holder name. I'm doing that. If I want to display the new password changed, I can actually do that also. Okay, so I can do that. I can pass on and I can use it, but not the members. I can use change password method and I can do that. Okay, obj dot change password, new password, and since we have a display here, so I don't have to do anything else. Object deposit, withdraw also have display options, so I don't have to do anything else. I don't have to put it into system.out.println. It is there. But if I try to access account number, it will throw an error. Let me first run this and show you. It is just using the methods. See, this works fine. Password changed successfully. The new password is now there. It is called new password. We have not displayed the password, but we are just displaying the message. Okay, now let me remove this and what happens. Okay, the comments I have removed, and if I try to access account number directly using an object, it cannot be accessed because it is a private member. It is declared as private. It is encapsulated, so we cannot access account number here. So I just put a comment here and then we can go ahead without using it, right? Fine. Okay, so let's go back to this. So you can see that I've explained it already, that in the balance example, you cannot access anything if it is declared private. You cannot access it in the main class or any other class, but within the class the data members can be accessed, right? Okay guys, so this is what we have in encapsulation. Encapsulation helps you in protecting your data from outer interference, right? Now we'll be talking about polymorphism, inheritance and abstraction in the coming lectures, and I've taken polymorphism not abstraction first because we need polymorphism and inheritance first to understand abstraction, right? So we'll be talking about polymorphism in the next video lecture. Till then guys, have a nice time, enjoy the videos, enjoy learning, keep growing. Have a nice day. Thank you.